Hello, calculus students. Here we are reviewing for the Chapter 6 test. You can use your calculator to help check work. But mainly, this is a test that you're going to do by hand. Find the indefinite integral of this. Well, the first thing I see is that it's factored, and that's not going to help us with the indefinite integral. So I'm going to expand it out and say the integral of 2x squared. That's the first. Outer would be minus 3x and 4x, so that'd be plus x minus 6 dx. Now we can crank up each part. 2x to the 3. Notice I take the 2 power and crank it up one because we're doing the antiderivative, and divide by the new power. This is x to the first, so when we crank it up, it'll be x squared over 2 minus 6x, and don't forget your constant of integration. There you go. All set with that. Let's check out the next one. I believe on the TI-89 somebody... Oh, now look at this. This is what the TI-89 says. Let's see. Be careful, kids, here, because on the T-89, when you do the antiderivative, it doesn't include the constant of integration, but it checks out. Okay. Find an equation for y given the derivative and a point on the curve. So it's actually dy equals 3x squared minus 1 dx. I just separate the variables like that, so when I do the antiderivative of both sides, it makes sense, and we get a y on one side. So you get y equals, well, we're going to crank it to a power 3x to the 3 divided by 3 minus x plus a constant of integration. And we can figure out this constant now by putting in 0, 2. This is called the general solution. We can get a specific solution by putting this point in. So 2 equals 3, it actually ends up being x cubed, so it's 0 cubed minus 0 plus c, so c equals 2. So we end up with y equals x cubed minus x plus 2 for our specific solution. Now on the calculator to check this, you could actually just take the derivative of this and make sure that 0, 2 works in. Because the calculator is only going to do the antiderivative of this. It's not going to tell you the constant of integration. You have to figure that out. Now, use acceleration as negative 9.8 meters per second squared. A baseball thrown upward from a height of 2 meters with initial velocity of 10 meters per second. So 10 meters per second, our initial height, determine the maximum height, so the initial height equals, the initial height equals 2, and the acceleration is negative 9.8. We have to work backwards and get our formula. Velocity is the antiderivative of acceleration with respect to time. So velocity equals the antiderivative of negative 9.8 dt, and so you get velocity is negative 9.8 t plus some constant of integration. Well, let's figure that out right away. At time equals 0, velocity naught equals 10. So 10 equals negative 9.8 times 0 plus c, so c equals 10. So what we have so far is that our velocity is negative 9.8 t plus our constant, which is 10. Now, determine the maximum height of the ball. How are we going to get that? We're going to need a height formula, and we're also going to need to know when that height happens. So let's get our height formula. Height then will be the antiderivative velocity, so the antiderivative of negative 9.8 t plus 10 dt with respect to time. So again, crank it up, negative 9.8 t squared over 2 plus 10 t plus some constant. And I think you have a suspicion of that when at time equals 0, h equals h naught equals 2. So we get h equals negative 9.8 divided by 2 is negative 4.9. t squared plus 10t plus 2. There's finally our formula. Now determine the maximum height the ball achieves. When will it achieve its maximum height? When is h at a maximum? Well, we could take a look and just look at this graph and find its derivative, but you know we have the derivative. Saying the derivative, it's when the velocity equals 0. So see the two approaches there? So there's two conceptual approaches. Either you find the max of the h graph, or you know velocity equals 0 at the top when you throw a ball up in the air, right? It's a velocity of 0 up there. In either case, you're going to set the derivative of h with respect to time equal to 0, and the derivative is the velocity. So essentially, either way you look at it, you're setting the velocity equal to 0 and find out when that happens. So negative 9.8 t plus 10 equals 0. Negative 9.8 t equals negative 10. So t equals 10 over 9.8, or 198ths, a little over 1 second. Now, to actually find the height, we have to use the formula here. So let's take our formula. Take the formula. Okay. And let's move that to the next page where we have a little more room. And put in t equals 100 over 98. And this is best done in the calculator. You could do synthetic division, but with that 198, that's going to be a pain. So height equals negative 4.9 times 100 over 98 squared plus 10 times 100 over 98. Okay, and we end up with a height of 7.102 meters. All right, now 4. Evaluate the definite integral by hand. You may check your answer with a calculator. All right, so to do this by hand, we're going to do the antiderivative first, and we end up with 3x cubed over 3. That's just a constant multiplier, comes along for the ride, plus 2x. And then, by the fundamental theorem of calculus, we're going to evaluate this from negative 1 to 2. Let's simplify this down to x cubed plus 2x, evaluated from negative 1 to 2. So you've got to put 2 into this expression and then negative 1 into this expression. So we get 2 cubed plus 2 times 2, all of that minus negative 1 cubed plus 2 times negative 1. So that's 8 and 4 minus negative 1 and negative 2. So that's 12 minus a minus 3, and we get 15. And that checks out with what's on my calculator. Remember the calculator command on this. Integral, left parentheses, let's look at the commands again. 3x squared plus 2, 3x raised to the 2 plus 2, comma, x going from, now the limits of integration, negative 1 to 2. So that's how you can check it on the TI-89. Okay, now it's an interesting problem where you're given a lot of information, but you're not given the actual function f of x. We're given that the integral from 0 to 3 of f of x dx is 10. From 3 to 6, it's negative 1. And from 0 to 3 of g of x is 3. So find all these. Integral from 0 to 6. Well, we can do this by adding up the integral from 0 to 3 of f of x dx plus the integral from 3 to 6 of f of x dx. And that's just then going to be 10 and negative 1, and you get 9. Now this one, little trick question. Integral from 0 to 0, that uses this idea, the integral from a to a of f of x dx always equals 0. Because basically you've taken your vertical lines and squished them together. So it's 0 because you've got the same numbers for the limits of integration. Now the integral from 0 to 6 of 3 f of x dx, the constant multiplier can come outside. So we get 3 times the integral from 0 to 6 of f of x dx. And we can take our answer from above, 3 times 9, and we get 27. Now let's pin this down because we might have this as needed information. And let's go on to the next batch. Integral from 0 to 3 of f of x minus g of x dx. Well, you are allowed to distribute the antiderivative over subtraction. So this becomes the antiderivative from 0 to 3, or the integral from 0 to 3 of f of x dx minus the integral from 0 to 3 of g of x dx. And that we can look up here, that's 10 minus, and the g from 0 to 3 is 3, so we end up with 7. Find the integral from 6 to 3. Well, we don't have anything like that, but we have this 3 and 6. And there's a rule that if you switch the limits of integration, and say this is the integral from 3 to 6, we'll get exactly the opposite answer we had before. So it'll be the opposite of this integral from 3 to 6 of f of x dx, which was negative 1. So negative 1 is 1. Now, let's set up a definite integral that represents the area of this region, then use a geometric formula to calculate the area. So we need the equation of the function itself. This is a line that has a slope equal to over 1, down 1, over 1, down 1. I think you can see that if we go from 0 to 5 to 1, 2, 3, 4, 1, that's going over 4 and down 4. That's a slope of negative 1. Formally in the equation, 1 minus 5 over 4 minus 0, negative 4 over 4, and you get a slope of negative 1. And the y-intercept is clear on the graph there at 5. So we get y equals negative x plus 5, which equals 5 minus x. Okay? And there it is. There's that function. Oh, I'm sorry, I didn't see that. That would save us some time. That's the function. Our other boundaries then are the two vertical lines like this and the x-axis itself. So we're trying to do the integral of 5 minus x dx and go from the x-coordinates of 0 to an x-coordinate of 1, 2, 3, 4. So go from x equals 0 to 4. Okay, that's setting up the integral. Now use a geometric formula to find the area. You got a couple choices on this. This area under the curve, we could divide up like this. We could say the triangle plus the rectangle. And the triangle is going to be 1/2 the base, which is 4, times the height, which is 1, 2, 3, 4. The rectangle is a 4 by 1 rectangle. So you get 8 plus 4 equals 12. And that checks with the answer off the calculator. You could also go ahead and set up a trapezoid. Remember that trapezoid rule? It's the average base times the height, or the average height times the base. Average, in this case, let's use average height times the base. So we go from 5 down to 1, we'll take the average of that, times the base, which is 4, and you get 3 times 4, and again we get 12. Okay, 7. Set up a definite integral that represents the area of the region shown, then integrate to evaluate. So in this case, we can't use a geometric formula, but we can say we've got the integral from x equals 0 to x equals 3, 0 to 3, of f of x, which is x minus 3 squared, dx. We expect something positive, and just as kind of a check, you can see, yeah, we've got a full 1 there, 2, 3, 4, 5, 6 maybe. Now I got 9 off the calculator, so I'm a little leery of that. I may have forgotten to square the inside function. We'll check that in a bit here. Let's start going ahead with this. Now be careful here. Let's not, this is inside the squaring, so we're going to expand this out and say x squared minus 6x plus 9 dx. So now when we crank this up, it will be x cubed over 3 minus 6x squared over 2 plus 9x evaluated from 0 to 3. So that's x cubed over 3 minus 3x squared plus 9x evaluated from 0 to 3. So we're going to put 3 in, 3 cubed over 3 minus 3 times 3 squared plus 9 times 3. And from all that we subtract off when we put 0 in. And that's just going to give us nothing because we have no constant terms. So that's all 0. This will be 9 minus 27 plus 27. And we get 9. Well, sure enough, we get 9. And I don't know why this looks like, maybe it's the scaling or something. I mean, if I looked at this whole thing, this would be 3 by 4, which would be 12. And we have a lot less than half here. So something seems fishy to me here. I think I see what the problem is. When I wrote this x minus 3 squared, this is actually x minus 2 squared. Yeah, x minus 3 squared would go through 0, 9 way up here. So it's a bad graph. Let's get that replaced. Yeah, because this is all valid steps here. So yeah, bad picture. Sorry, people. Okay, and here's the better graph. And here we have from x equals 0 to x equals 3. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that looks like an area of 9. Okay, find the average value of the function over this given interval, negative x cubed plus 3x plus 2. So for average value, we're going to take the area under the curve, the integral from negative 1 to 2 of this function, negative x cubed plus 3x plus 2, dx, and divide it by 2 minus 1, because that's basically the area under the curve. That's the interval. So we're going to find out what's the average height of all these points on this interval of this cubic. Let's take a look at GeoGebra, see what we might estimate for a picture of this. As you recall, the average value then is going to be, if we took all this big area from negative 1 to 2 and melted it down and refroze it, we'd end up with a block of ice that'd be 3 wide, but how high? Well, I checked on the calculator and it turns out to be about 2 1/4. So it's actually, we're going to remelt this and come up with something that looks like this. And so this is our average value. So let's come up with that over here. To do this integral, we're going to do negative x to the 4th over 4 plus 3x squared over 2 plus 2x, and evaluate that from negative 1 to 2 and divide the whole answer by 3. So this takes quite a bit of doing here in terms of calculating with the arithmetic. You got to put 2 in, so it's negative 2 to the 4th over 4 plus 3 times 2 squared over 2 plus 2 times 2. Take all that and then subtract off. What happens when you put negative 1 in? Negative 1 to the 4th over 4 plus 3 times negative 1 squared over 2 plus 2 times negative 1. And all that will be divided by 3. So let's work on our first term here. We got negative 16 over 4, so that's negative 4 plus 6 plus 4 minus negative, that's a negative 1/4. That's squared, so that's plus 3 halves minus 2. So from all over 3. So from this we've got 6. And let's distribute this, adding the opposite of. And we end up with a 4th minus 3 halves plus 2 all over 3, which is 8 plus, let's see, a 4th is a 4th minus 3 halves, which is 6/4 all over 3. 8 plus negative 5/4 over 3. Let's multiply top and bottom by 4. We get 32 plus negative 5 over 12, or 27/12. You can take out the 3 9/4, and that checks with our answer. 9/4. Finally, no, it is number 9. Find the indefinite integral by substitution. Your final answer should be in terms of x. Okay, so yeah, so we don't have limits of integration here. We're doing the antiderivative. The nasty thing here is this thing inside the square root. So let's let u equal the thing inside the square root, x cubed plus 3. And so du is 3x squared plus 0 over the 3 there, dx. And isn't that handy? We've got the 3x squared dx right there. So if I rearrange this as the integral of the square root of x cubed plus 3 times 3x squared dx, we can call this part u, or square root of u, and all of this then becomes du. Now it's a lot easier problem to do, because now you're just doing the antiderivative of u to the half du. So crank it up a power, u to the 3 halves over 3 halves plus some constant. And so you get 2u to the 3 halves over 3 plus a constant integration. And now we just have to unsubstitute. Remember, u is x cubed plus 3. So it's 2 times x cubed plus 3 to the 3 halves, all divided by 3, plus our constant of integration. And that checks with the computer answer. Finally, evaluate the definite integral by substitution. So the idea is you could expand this all out with a plus b quantity cubed, a cubed plus 3a squared b plus 3ab squared plus b cubed, and then multiply through by x squared. Oh, what a mess. Instead, though, if we let u equal x cubed plus 1, then du is 3x squared dx. And we can get what we're looking for by putting a 3 inside here and compensating by multiplying by 1/3 outside. So it becomes 1/3. I'm also going to change the limits of integration because x goes from 0 to 1. U, if u equals x cubed plus 1, goes from 1 to 2. So it's 1/3 the integral from 1 to 2 of u cubed du. Remember, u is all this x cubed plus 1. And that's a lot easier a problem, right? Because you can say 1/3 u to the 4th over 4 evaluated from 1 to 2. So u to the 4th over 12 evaluated from 1 to 2. We get 2 to the 4th over 12 minus 1 to the 4th over 12, or 15/12. Take out the 3, 5/4. And I believe that checks with our answer as well. Okay, I hope this helps. Good luck on the test. Flange out.